Afternoon. Let's continue with the course. So yesterday we learned how to define different type of objects in R. So if you remember, if I want to create a vector, we use C or sec or rep. These are the main functions to create vectors. If I want to create a matrix, then the function was matrix, or if I want to combine vectors in columns, or if I want to combine vectors in rows, I could also use these two functions. If we want to create a data frame to combine qualitative and quantitative variables, then I can use data point frame. This was the function. If I want to create a factor, and this was useful for qualitative variables, then I use factor. Or if I want to combine different type of objects, then I have to create a list with the function list. Okay? And we also learned how to assess two different parts of an object, mainly vectors, matrices, data frames. We assess to the elements with the brackets. In case of list, then we have to use double brackets, or if we have names, we can use the dollar symbol with the name of the variable we want to assess. And also we can use, we could use logical conditions in order to get subset of data. So for instance, we consider again the dataset MSFT in the library RUGARCH, data MSFT. And let's do the last example in the slides. Consider this data set. If we want to select the volume on trading days on which the closing price was equal to or greater than 72 and the opening price was lower than 71.5, then I have to go to the data set. I have to say which rows I want to obtain, and these are the rows that satisfy that the closing price dollar close was greater than or equal to 72, and the opening price dollar open was lower than 71.5. And I want these rows, and in this case, in this example, I want just the volume, the column corresponding to the volume, so comma, MSFT. Sorry, the library was time series, no? Okay, this data set is contained in the library time series, so I load the library, then I load the data set, and then I go to the data set. I want these rows satisfying these conditions, and I want this column.
There was an exercise about removing not available numbers. And how do you do it? I did, but I don't think it's very clear.
About?
Removing MA from a data frame. For example, if you have an not available number, what's the easiest way to do it?
Well, to remove the NA, you can use, for instance, this function is true if you have an NA number. So you can use this to see the indices of the subset, which are NA. And then you have, once you have the indexes, you remove them with minus the number of the indices. So for instance, let me see if I have here an example. Oops. First I'm going to change the working directory. I think this data set, okay, data 1. Okay, and this is the first step. And I think that it's also which .na, I don't know if this function exists, no, but you can do which is .na data 1. This is the index, is in columns, so 5, 6, 7, 8, 9. This is the element which is not available. Mm-hmm.
Getting back to the SF example, you filter the data set and you choose the volume.
Mm-hmm.
And the data, the first column is the date.
Yeah, this is the row name. This is nothing. Well, it's information, but it's not data. It's the row names. So you have column names here, volume, and you can also have a row name.
It's not part of the data set.
No, the data set. It's part of the data set, but it's not inside the data set. I mean, it's not, this is 3. This data set has 3 elements, and the elements are these 3 numbers, but you have more information because you have the row names of these elements and the column name. Mm-hmm. You can get it, or you can get these values from the data set also, but it's not part of the data frame, of the contents of the data set. Sorry?
I want to filter the data set by the year of the date.
Yeah, this, I mean, you have to deal with this column here and extract the year from here, and you can do things with it. I don't know if that's... Okay, this is, I think that this is the function. No, I don't remember now the function to get this information in a vector and then work with it as another object in R. Mm-hmm. I can check it later if you. Okay. Well, so now we are going to learn how to summarize the contents of an object in R. There are different ways. So we have 2 functions that are helpful for summarizing the contents of an object. One, I mentioned both of them yesterday, I think. str gives us the internal structure of the object, and summary gives information about different things of an object depending on the class. For example, if we apply summary to this data set, we get something like this. For each column, we obtain the minimum, maximum, mean, median, and first and third quartile. Okay? So this is the way in which R summarizes this data frame. And there are also other function, sorry, to summarize information. So we are going to work with this data set, which is included in the RUGARCH package, the MVP. So library RUGARCH data the MVP. Well, this is the data set. This is the first part, and if you want to know, if you want information about this data set, as always, we ask for help on the data set. So this is the information. The variables here are the daily percentage nominal returns, and in the second column, a dummy variable that takes the value 1 on Mondays and other days following no trading in the Dutch mark and British pound US dollar market, or 0 otherwise. Well, so we are going to work with these two variables. One is quantitative and the other is qualitative, and we are going to learn different functions to summarize the information in these two columns, okay? So first, I'm going to save the columns separately. So I'm going to call red the first column, so the MVP column 1, or $V1 is the same. I can do also like this, red the MVP $V1. So I have the returns here, and for the days, well, this is qualitative, so 0 means not a Monday and 1 means Monday, so I'm going to save it as a factor. Okay, so this is a factor of the second column of the data set. And I'm going to say the levels, the labels for the two values. 0 is not Monday, and the second value is going to mean Monday. Okay, so I can add labels to the values in a factor. So I have these two variables, days, Monday, Monday, not Monday, etc., and this is a factor, and red is quantitative. Well, so how can I summarize? I'm going to start with these qualitative variables. How can I summarize the information in this vector? So I can use the function table. Okay, and this is the frequency table of this variable. So there is 1,518 not Mondays and 456 Mondays. Well, and how can I summarize information in the quantitative variable? Well, I'm not going to do a table, so I will try to compute a mean or variance or quantiles, etc. Okay, so we can compute the mean of the returns with the function mean. And this is exactly the same as doing the length, the sum of the values divided by the side, which is the length of the vector. This is the mean. Or I can compute, for instance, the median of the returns with the function median. And there are different or a lot of functions that operate on a vector in R and that give us information or summarizing information about the values for mean, median, var for the variance, SD for the standard deviation, quantile for the quantiles, range, IQ, R, diff, etc. Okay? So for instance, the variance, as I say here, Okay. The function var computes the variance with the denominator n-1. So this is the variance of the returns. I'm going to write here. The standard deviation, which is the same as the square root of the returns. What happened here? Oh, the square root of the return, no, sorry. The square root of the variance of the return. Okay. Well, and the function quantile give us, by default, the quartiles, minimum and maximum, but I can specify also which quantiles I want to compute. So for instance, I can create this vector here with the numbers from 0 to 1, with the step 0.1. Okay, and if I apply quantile to the returns, but with this vector, then it gives me these quantiles. Or just one quantile red 5, this is the median of red. Okay. Well, the interquartile range is the same as the quantile red 0.75 minus quantile red 0.25. And there are many other functions that apply directly to a vector and give us information about some features or characteristics of the data. And there is also a family of functions which is quite useful in R, and this is the apply family of functions. Well, these functions, included in this family of functions, are apply for matrices and arrays, lapply and sapply for lists. mapply is like a multivariate version of sapply, and tapply for summarizing data sets divided into groups by some factor. So we are going to see how we use these functions in R. Okay, but these are quite useful, and they avoid us to use loops many times. Okay. So let's go to apply, and it works for matrices. So we are going to consider a matrix. We created yesterday this A. A is a matrix with the numbers from 10 to 15, with 2 rows and 3 columns. This is A. I can apply a function to A. If I want the function to be applied to the rows, this is the first dimension of A, and the function that I want to apply, for instance, is the sum. So I want the sum of the rows. So the first row sums 36, and the second row sums 39. If if I want to apply a function to the columns of a matrix, then I use apply to A, to the second dimension, and the function that I want to apply. So this is essentially the same as we did yesterday with the function row sums of A or call sums of A. But apply is much more flexible because I can apply a sum, but I can also apply a product or another function that I want to use, okay? So for instance, apply a product or the mean or the variance or whatever. Or I can define my own function and apply it to the rows or to the columns of a matrix. And if I have an array, then I will have 1 for the first dimension, 2 for the second dimension, 3 for the third, 4 for the fourth, etc. So this function works for matrices and in general for arrays. Well, in this family we have apply, we have also tapply. Tapply is for factors. Okay, so for instance, we want to compute in this data set the MVP. I want to compute the mean of the return values on Mondays, and I also want to compute the mean of the return values on not Mondays. Okay, so I want to apply a function to different parts of a data set. So I can use tapply to read to the returns, taking into account the levels in the factor days, and the function that I want to apply, for instance, is the mean. Okay, so this is the mean of the returns not Monday, this is the mean of the returns on Monday. And here I can put any function that I want, okay? And we have also, for lists, we have sapply or lapply. So for instance, I have my list, which is a list with a vector with numbers from 1 to 5, and a matrix, well, the matrix A that I defined before, and another vector with the numbers from 7 to 15. Okay, so this is my list. I can apply to the list, to my list, the function sum, for instance. And it applies the sum to the elements in its component of the list. And the difference between lapply and sapply is that lapply gives us a list and sapply gives us a vector. Okay? And there is this mapply function. This is the syntax is a bit different, so I'm going to apply the function, for instance, rep 1 to 4 and 4 to 1, and this is what the function does. So it repeats the number 1 4 times, and then repeats the number 2 3 times, and the number 3 2 times, and the number 4 1 time. Okay, so applies the function to each of the components that I write the second and the third argument. So these functions, mainly apply or tapply, well, I use them a lot in R because we don't have to write loops, for instance, using this kind of functions. Okay, any question? Well, so...
Does it overload? Can you overload this function?
Can I, sorry?
Does mapply overload? Can you use different classes?
Sí, sorry. Here you put a function, and here you put the argument that fits with the, and you can use an apply inside another apply, and well, so I think now it's a good time for you to try this that we learned until this point, because now we are going to start with plots. So I suggest that you could try with the exercise number 28, which has a bit of everything. So you have to read a data set, and you have to get information from the data set, or use these apply or t-applied functions. Okay, so maybe 15 minutes or something like that to try with this exercise, or you can ask me if you have doubts on any other thing. Okay.
So this is from the last set.
Yeah, this is the same as the same document as yesterday. I also sent today the exercises. I think that they send it to the list of students.
Hopefully, yes.
Yeah, but it's the same as these days, same document. And function table to compute frequencies. Okay? We can also use the function table to compute 2x2 tables. So just with a comma, I want to know how many men and women survive or not. So sex, comma, survive, and then 290 women survive, but 96 didn't survive, and for the men, 135 survive, and 522 didn't survive. And you can compute percentage. Once you have this, you divide by the size, and then you get the relative frequencies and those kind of things. Plots in R. Well, R includes tools to display a wide variety of statistical graphs. There are general packages for basic graphics, programming, such as graphics or lattice, and many other packages that give us specialized graphics, RGL, ggplot2, etc. Well, if you want to see some examples on the kind of plots that we can do, you can select demo graphics. Click return to start. Okay, so this is a simple plot, a pie plot here, another one, kind of box plot, distance between Brownian motions here, and the code is here. If you want to reproduce them, you have the code in the left. Or like a time series, or a histogram, or Pateiro plot. And well, this is with the data of iris or iris, and this is with the colors of the species, or a map like this one. Well, there are different kind of plots that we can do with R. Okay, this is just a demonstration. Well, the thing is that there are two main groups of plotting commands in R. These are the high-level plotting commands and the low-level plotting functions. Okay, so the high-level plotting functions create a new plot on the graphics device, and the low-level plotting functions add more information to an existing plot. Okay, so the high-level plotting functions open a new graphic, and the low-level plotting functions add information to a given plot. Well, the basic plotting function in R is plot. And the plot, as I said yesterday, is a generic function, so it can be applied to different types of objects. And here, if you want to see the different plot functions that you can use, with methods, you obtain the list. So there is a plot density, a plot data frame, a plot TS for time series, a plot ECDF for the cumulative distribution function, etc. Okay? So a simple case. So suppose I want to represent the function x squared. So the thing is that I'm going to create is like a scatter plot. So here I define the values of x. X is a sequence, for instance, from -10 to 10 with length 100 points, and then y is going to be x squared. And I'm going to represent x versus y, so plot x comma y. Oops. And this is what I get, okay? So by default, these are points, because it's like a scatter plot. We only represent the pairs of points that we have defined, okay? So this is plot x versus y. There are many ways in which we can give the same information. We can write like this, or we can write plot a list with components x and y. This is the same. This is the same, or we can do plot a matrix. So for instance, I'm going to do it in 2 steps. I'm going to create a matrix with column x and column y, and I can plot A. And the result is the same. Okay, so this is the usual way, x comma y, but I can also represent the data if it's in a matrix with 2 columns, or if it is in a list with components x and y. And I can also use like a formula, plot E as a function of x. Okay, this is the same. This is used in different functions in R. For instance, for regression models, this kind of expressions, which are formulas, can be used. And in particular, in the plot function, you can use this expression to represent y as a function of x. Okay? And what happens if I only plot y? If I only plot y, here I have, in the x-coordinate, I have the index of the element. Okay, so this is what is different. You can plot x and y, and then we have, look here. Here we have x. If I just plot y, I have the index x. Okay? Well, I'm going to mention one thing which is different if I use RStudio or if I use R. Here, if I do these different, these 2 or 3 plots that I have here, I have all of them here. Okay, I can go. I have the different plots in RStudio. But if I do the same thing in R, if you work in R here, I have this plot, and once I plot this one, which is different, the last one, this is here, but I missed, or I lost the other one, okay? So it plots over the screen. So if you want to do this plot and I want another one in a different device, then in Windows I use oops. Okay. Well, for instance, plot 1, 1, this is my plot. Now, if I want to open another device, I use Windows. This open a new device different from the other one, and then if I plot here 2, 2, I get the other one, okay? And if I don't do this, for instance, I have now this one active, so now plot 3, 3 is here, and I lose the other one, okay? And in Mac, you can use, instead of Windows, X11 to open a new device also. But if you work with RStudio, we don't have this problem because you always get all the plots and you can move from one to the other with the arrows here, okay? Well, I said that the plot function is a generic function, so if the argument of the plot function is a factor, for instance, I had yesterday, we wrote this factor with the block type. This is a factor. If I plot this factor, then it gives us a bar plot, okay? Or if I plot an object of class time series, as these air passengers that we also use, then the plot is plot point time series, and it gives this image, okay? So it depends on the class of the object, we get different type of plots. Well, the plot function has a lot of arguments to change the appearance of the plot, and here I chose some of them. For instance, type is the type of the plot. By default is P, so we see the points, but you can use L for lines or H for vertical lines, etc. There are different type options for the type argument. Main, if you want to add a title to the plot, sub for a subtitle, X label, Y label for labels for the axis. If you want to change the limits of the axis, you can also do it with X lim or Y lim, or if you don't want to draw the axis, then you can use axis equal false, and then the axis disappear, okay? And you can also use extra parameters to control aspects, for example, the color, the type of line, the thickness of the lines, etc. Okay, so here we have some different examples using these arguments, but there are a lot of arguments for the plot function, okay? So for instance,
when you have the bar plot, you have a type, for example, it's already choosing the bar plot. Can I choose for a pie plot instead?
What?
I want a pie plot.
Yeah, pie plot is a different function, and we will talk about it later. But the plot function, by default, with a factor, draws a bar plot. And there is also a bar plot function if you want to use it. But, okay? And there is a function to draw a pie plot and other things. Well, so for instance, in the first case here, I plot X and Y. The type is a line, not points, okay? But this is the appearance of the line, and this makes that the line is dashed, okay? If I remove this argument here, it could be a solid line, and since this is equal to 2, this is a dashed line. Color red, we can use col with the name red, or col equal to 2 in this case, is the number for the red color, or we could give a specification of the color also with RGB or something like that, okay? But the usual is to use the names or the numbers for the colors. I think that here I have something, yeah, if you want to see the colors that you have, then with demo colors you will see the numbers and the colors that you can use. In this second case, I Here I also wrote an label for the x-axis here, x, and here y, and a main title plot function here. In the second case, I plot the factor block, so this is a bar plot with a title, bar plot, in color green, and with a label here in this axis, absolute frequency. And in the third case, I plot the time series, but I also write a title here. I change the color to the blue, which is the number 4, and is thicker. The thickness of the line is 3 instead of 1. So this is a bit thicker, okay? Well, and what if I want to add something to a plot that I already did? Well, then I have to use the low-level plotting functions. That they can be used to add extra information. So for instance, if I want to add a point, or if I want to add lines or text or a legend to a plot, to an existing plot. Can be executed, these functions can be executed only once a high-level plot has been created. So for instance, I cannot use lines if I try to use lines without an open plot. For instance, here, this is an error because we have not a plot, the plot point new has not been called yet. So I have to plot something, and then I can add lines or points or whatever, okay? So we are going to see some examples also here. So for instance, this plot here, I represent the sinus function and the cosinus function, okay? So the first thing that I do is define the x. So x is going from 0 to 2 times p, 10 numbers between 0 and 2p, okay? And then I compute the sinus of x. And I draw plot x and y1 in a solid line type equal L, in color red, in red color, dashed line, this is the type of the line that I want to represent, and I change the label here to put y. Okay? So this corresponds to this function in red. So up to this point, if I run up to here, then I get the sinus function. And then I have this plot, this is open, and I want to add the line of the cosinus function in green, so I compute the cosinus of x, and I add a line with the function lines. A line of x and y2 in color, in green color, and this is the thickness of the line, okay? So this adds this line in green here. And in this case, now I want to add a point in blue at this position, some text, a line vertically at this point, and a legend to the plot. So I have this, I created this, and now I add a point with the function points in P0. Well, I said 2, 3, but I wrote here P0, okay? In color in blue, and this is the kind of points that I want to represent, PCH, okay? By default, it's an open point. If you want a solid point, for instance, this is the number that you want to choose, but you can try with different numbers to see different kind of points, okay? Then I add a text here in P0. The text is point, and the position is 3, and this means that it's going to be written up to the given coordinate here. So you can change post equal 1, 2, 3, or 4, left to the left or to the right, up and down. Okay. I can add a vertical line with this function, up line, to add vertical lines or horizontal lines. Here I want a vertical, so I choose the argument v equal to the value that I want in color blue, and this adds this line here, this vertical line here. And finally, I want to add a legend to say that in red I have the sinus function, and in green I have the cosinus function. So legend, where I want the legend, the bottom left or top left or bottom right, or a coordinate where I want to write the legend. The test inside the legend, which is a vector, the first component is sine, the second component is cosine. The colors, the sine is in color red and the cosine is in color green. And finally, the type of line that I want to represent. The sine function is represented with the dashed line, so this is 2, and the cosine function is represented with solid line, which is the 1. Okay? And we can also annotate graphs outside the plot region, and here we have some functions to do this: title, mtest, or axis. So, for instance, in this case, first I compute x and y, and I represent the sinus function with a solid line, well, not a dashed line because I changed this to 2 in red, without any annotation and without axes. So I'm going to run this part to see how it looks like. So up to here, this is what I get. No axes, no annotations, X label, Y label, titles, etc. Okay? Now, I want to add an axis below and an axis on the right. So I have this function, which is a low-level plotting function that adds information to a given plot. In particular, this creates the axis here, and this one, the axis in the right. Now, I want to add a title, a main title, and a label in the X coordinate. And finally, I add some lines, for instance, oops. Okay, this line here, this test is written in the left because I use side equal to, and in the line 0 of this margin. And this is written also in the left, but in the second line of this margin. Okay, so you can change the side and the line to write information in these parts of the frame. Mm-hmm. And what if I want more than one graph in the same graphic device? So then I have to divide the plot area into different parts. So in particular, if I want something like this, 1 row and 2 columns, then I need this expression here. Par and row equal to, and this is where I specify the dimension that I want. I want 1 row and 2 columns, so this divides the space . Well, this is going to do nothing. This is nothing, but now when I plot the sine function, it is plotted in the first part, 1 row and 2 columns, and now the second plot, it is going to be plotted in the second part. And the next time that I plot something, it's going to remain 1 row, 2 columns. So if I want to go back to the previous case, then here 1, 1, and then each time I plot something, it's as always, okay? And you can check the help for this par function because this controls a lot of things in the appearance of the plot, and there it has a lot of arguments to change margins or this kind of things, or width or height, or a lot of things. So you can set before you do the plot, you can set these parameters here and then do the plot with those parameters, with those arguments. Well, and apart from the plot function, which is the main high-level function, plotting function, there are other high-level plotting functions in R. And here we have some of them. So for instance, bar plot creates a bar plot with vertical or horizontal bars. A pie, the function pie draws a pie chart, hist to compute an histogram, box plot to box and whisker plots, persp for three-dimensional data. And it's always the same. These are high-level plotting functions, and once I have my main plot, then I can add whatever I want with lines, with points, with text, etc. So it's always the same. Once we have our main plot open, then the rest is always the same. So for instance, we had this DMVP dataset, and in the DMVP dataset we have the returns and we have the days, and the days is a categorical variable, so I can, for instance, draw a bar plot with this data. So I have days, I compute the absolute frequencies, and I represent those frequencies in a bar plot. Okay, so I get this bar plot here, colors 2 and 3, color red and color green, with a title here. So the arguments are the same as in the plot function. Or in this case, if instead of a bar plot I want a pie chart, then I compute a pie with the frequencies, with the absolute frequencies of the days. I add the title and I add the colors 2 and 3. Okay? Or I'm going to do this one if I want an histogram. For instance, consider the variable red, the returns, which is a continuous variable, so I can represent information with a histogram. Okay? So, okay, so this is a histogram. By default, these are absolute frequencies. If you want a histogram with area 1, then frec, the argument is frec false, and this changes the scale here. Okay, so this is a histogram with area 1. And if you want to add an estimation of the density, kernel estimation, then you can use this function density, computes the kernel estimation, and I add to the plot the lines corresponding to the density estimation, okay? So this part here computes the density estimation with a given bandwidth, and here I choose the color and I choose the thickness of the line, and I add this line in red to the plot. Okay? Or more examples, for instance, for the returns, if you want to represent a box plot, you use box plot red. But it's better if we see the returns depending on the days, Monday, not Monday, so you can use like this. Again, a formula here, red as a function of the days, and then we get this box plot represented here, okay? And there are other high-level plots, and this is just an example on how to create a three-dimensional plot. So for instance, I'm going to represent here the density of a normal distribution in the b-dimensional case. And for that, I'm going to use the function persp, which is the main function or the simplest one to represent three-dimensional data. Although there are other packages, for instance, the RGL package is quite useful also for three-dimensional data sets. Okay? So I'm going to explain what I'm doing here because I also want to talk about this function outer, which is quite useful in R. So this is a library that includes functions for multivariate densities for the normal multivariate distribution. So in particular, it has this function, the norm2d, that returns the density, the value of the density function at a given b-dimensional point. Okay? So in this case, I want to compute the function, the density function of a normal distribution in 0, 0, and this is the correlation parameter between x and y. Okay? And you can also change the mean if you want, but I didn't do it here. So this is the value of the density function. This is what this function do. So I want to use this function to represent the density of the b-dimensional normal distribution. So I'm going to use the function persp. And the function persp works like this. I have to give like a grid of values. Okay? So I'm going to use x from -3 to 3, 50 numbers, and 50 numbers for y also in -3, 3. So this is x and y. And now I have to give as the third argument the value of the density in each pair x and y. Okay? So for each pair of x and y, I have to compute the density. And how can I do this? Well, this is I can do that very easily with the outer function. So consider, for instance, this example. A is a matrix 1 to 6, 2, and 3. And B is a matrix, I don't know, 10 to 15, 3, 2. This is A, this is B. Well, the outer function, outer, allows me to compute something on each pair of components of A and B. So for instance, sum. Oops. Let me see. Sum is a vector function, so this is what I want. I want to sum each component of A with each component of B. Okay, so this is what the function outer does. So for instance, I have here A and Y. I'm going to write them again. These are my matrices. When I do outer, well, 2 plus 10 is 11. 2 plus, what it's doing now, oops. Oh, aquí. 1 plus 10, 1 plus 11, 1 plus 12, etc., 3 plus all of them, 5 plus all of them, etc. Okay? And what I get as a result, if I save this here, this is an array, okay? Because I need another dimension to save everything. But what the function, the outer function does is that it applies a function or a given function, for instance, this plus, with each pair of coordinates of A and B. So this is the function that I need in order to make the representation of the bidimensional density plot, because I have to compute for each pair of X and Y the density function of the bidimensional normal distribution. Okay? So here, for each pair of X and Y, I compute the normal density. And this is what I have to put in the third argument of this function, with a color in light blue, and this changes the perspective in which I see the plot, and this is what I get as a result. This is not dynamic, but if you use the RGL package, then you can do a three-dimensional plot and you can move it inside R. Okay? This is not dynamic, this is just a bidimensional plot, but with the RGL package you can also move the thing and change the perspective. Okay? Well, so I think it's enough for today, because tomorrow I will start with probability distributions in R. So this 10 minutes, 15 minutes, we can continue with the exercises, with the Titanic exercise or other that you are trying to do, and please ask me if you have questions or doubts. Okay?
I have one question. I can choose the size and the font and save as default for the plots.
The size? Yeah, you can change the...
But, I can save like a new default that when I do again, I don't need to do this. For example, if I'm working with Times New Roman or something, I can save this as default for the plots.
I didn't understand.
The type of the font.
The type of the font. Yeah, you can change it. Yeah.
But I can save this as default, as a new.
Yeah, with the par, I mean, the same as I did here. Well, I think, no, I remove it. Each time I do a plot, I put the arguments, but there are some arguments that maybe I want them to be fixed all the time. So before creating the plot, I use with par. Here I put all the arguments that I want to be fixed. So in particular, if I want that the appearance is 1 row and 2 columns, then I choose this equal to 1, 2. And if I want another thing to be something, then I can put it here. And each time I do a plot, it's going to take those arguments as default until I change this sentence here. So there are things that you can save as a default previously to the plots. And it's with this, if you check the help of this function, you will see a lot of arguments that you can set in the beginning to change the appearance of all the plots that you are going to do after that.